What is up, guys, and welcome to another episode of CCT. So today, we're gonna continue this theme of like just doing easy questions in the morning and ones that I've already done because I've done like mainly, not all of them. Maybe I'll do a new one. Um, but yeah, it's just like a healthy, relatively easy routine to do in the morning, and it keeps your skills strong. And then I do some harder ones maybe later on. Uh, so yeah, I want to bring you through this journey of just like a nice routine in the morning. Okay, so let's do same tree, symmetric tree, maximum depth. Okay, that's just really random. And I mean, let's see how long ago I did this one. 8 months ago. Alright, let's do it again. So, given a binary tree and a sum, determine if the tree has a root to leaf path such that adding up all the values along the path equals a sum. Okay. So, it's asking if there's like a path from. Wait, given a path. If the tree has a root to leaf path. Now, the only thing I don't know is if that includes. Does it have to include the 5 and like start up here? Or can it. Let me actually. It doesn't give you the answer on that. That is too bad. If the tree has a root to leaf, I think it does mean that it has to start at the 5. Okay. Let's just at least take that under the assumption that it has to start at the top one. So what basically is this? So you have 5. Okay, I'll just make one. So like 5, 4, 8. And so if you're looking for the combination 9, for example, or 10, that would be right here. And this is a root to leaf path. Remember, it has to end here. So if I said 9, there's no combination to 9 because you can't go just 5 and 4. So how I see this is I see this as like recursively trying out all the options and then evaluating once I get to the end. So when I say recursive, I also mean like depth first search. So we're going to try like here and then see what the sum is at this point. So remember, with depth first search, we always have this like current. And what the current's going to be keeping track of here is the sum. And by the time we get through this iteration of depth first search, it has a different current, and then here, whoops, it has a different current. Okay, so something with depth first search, there's kind of a recipe to it. Not that it's easy to do depth first search even if you have the recipe, but yeah. So you have, actually, let me draw this a little here. So we're going to return an int. Ooh. Okay, so the number one thing is this ending /base condition. And this is the formula for when you're depth first searching. You got to know when it's time to check if you got the result or not. You need to check when it's over, when you're done. And you're done, oftentimes it is once you get to the bottom of this. So we have to make sure that the current node that we're on is a leaf node. So that's our base condition, so leaf node. Two, I don't think this applies to, oh no, yeah, this could be an optimization. So this is like a pruning step. this is like if you can cut it off before you get to that base condition. So maybe we could cut it off if like we go 5 to 8 and we're looking for 10. 5 plus 8 is 13. It's already too much. We can cancel out this entire subtree, however long it is. So pruning. So when current sum is greater than the target. I mean, we're assuming there's no negative numbers. And then 3 is how you iterate through this tree. I mean, here, for example, we're literally given a tree, so you how you iterate. So sometimes with depth first search, it's not obvious how you iterate through options, let's say. But we're literally given a tree, so what we can do is just iterate left, do something on the left, and do something on the right. We already have this tree set up, and it's a binary tree. Like sometimes you have, with depth first search, you have multiple options, and then these have multiple options. But that's not what we have in this case. We just have a nice binary tree. 2 options at most, at each point. Okay, so now I think we should get to the coding part. Man, this redness annoys me. Should I restart things? Okay. Also, I didn't really discuss what the helpers are, or what we need here, because I think we're going to need a helper function, because we need more than these. What we need is a current node to keep track of where we are. We need a current sum. We can take in also the target sum. We'll just call it target. And yeah, that's it. Yeah. Well, I could technically just make current sum outside. Now I'll just do a helper. So bool. Oh wait, it's a. Oh yeah, you return just true. Okay. Bool helper. Why did I do that? Let's just return helper, or let's just call it DFS, depth first search. So we're going to give it, so the current node is going to be the root to start off. The current sum is going to be 0, and the target sum is going to be that. And yeah, so let's do bool DFS. So this idea of like making a helper and like wrapping it with an easier thing is pretty common. Just saying. So we can call this, that's your tree root, let's call this current node, let's call this current sum, and let's call this target. Okay, base conditions. So we have to first check if current is a leaf node. So how do we check that? We need its right side to equal null and its left side, whoops, to also equal null. And the thing is, we can, this is a little trick, because if this is null, then that returns false, but then this makes it true. And if this is null, it will return false, and then this makes it true, the negation. So if this is true, then you're at the leaf node. So then you have to decide if you're returning true or false. So so when you're at the leaf node, okay, yeah, we still need to add it. So current sum plus equals current node val, right? We didn't add this at this point because this is the iteration where we get this leaf node. So we need to add it on. Yeah. Okay. So then base condition. So let's just return current sum if it equals the target. Yeah. So if it equals target, that's great. Let's return true. If it doesn't, let's return false. Next, pruning case. So if actually, we need to do this always. Yeah, let's just put this out here because we need to do this for the pruning also. Oh, but then we also have the base case of like, I mean, there's a few orders you could do this in. Let's just, yeah, let's just do this. So if not current node, so if current node is null, well, we don't even, yeah, forget about that. We will assume, we will make sure that it's, no, we don't want to do that either. Okay, let's return false because like that path didn't work. So if current if current sum is greater than target, we're going to return false. Like the return false is like that path didn't work, and we'll probably use or somewhere to see if like any path works, right? So that would cancel out like, I mean, going to null is useless, but now we don't have to, we can pass in null for when we do the left and right stuff. So now what do? We need to see if, so DFS current, sometimes like when I don't know exactly what to do, I just throw it in, because I know I'm going to have to do something on the left side and the right side. Yeah, I don't need to add that to it right now, because that's the one I'm at. And then target, you just follow through like that. And that's going to return true or false if any path to the left equals the sum. So it's actually an or. I'm going to be returning this. If there's like any path to the left and current node, any path to the right with current sum and target. Okay, let's think of edge cases. So if the root is null, yep, we just return false, unless it's 0. I don't know about that case. We'll see. I mean, I would have asked the interviewer at that point. But, yeah. So then what we do here is we add the value to our current sum. And we check if you are a leaf node, then we can assess if the current sum is the target. So for example, if there's only one node, you add that value, and that one node is a leaf node, so then you can check if it equals the target and return true or false. If it's greater than, then we return false because we know that path didn't work. And what this depth first search is doing is it's saying that is there any path on the left starting from the root? And we could say starting from the root because current sum is starting from the root. So is there any path on the left side from the root to any of the leaves on the left side that equal the target, or any places on the right side that equal the target? And we're going to have a ton of pruning here. Okay, so let's check it out. Okay, so I didn't put those in. These are both ints. Okay, so we got true there. I'm actually curious what this is supposed to return. Uh-huh. Wait, what? But this is false. How did it even get past that? Current node. Runtime access to pointer. Well, hello. What? Okay, I don't even care. I just want to see what the answer should be, and I'll deal with that later. Okay, it is false. But why is this not returning false? What? If it's null, why would it be able to continue? What? But I'm checking if it's null pointer. Member access within null pointer type. Okay, but I'm checking. Okay, that is, I mean, what if I check here? If not root? Oh, I just say false. Okay, okay, fine. Alright, let's submit this. Okay. Oh, negatives are allowed. What? Okay. Fine. We can't do this then. We can't do any pruning. Sorry. Can't optimize that. Unfortunately. Yeah, let's just submit. Because that's why it wasn't working, because this is making sure that the current sum is not greater than the target, but that's assuming that there's only positive numbers, and I guess it didn't specify that, so there's no real optimization for that. Yeah, so I'm only faster than 42%. Huh, I wonder what I can do to make this faster. Oh, well, I just resubmitted it at 99%. Okay, it's just one of those Leetcode things. I'm pretty sure this is the fastest way. I'll update you if there's a faster way. And yeah, I hope you guys learned something by seeing me think through this process, and I'll see you next time. Bye.